So, okay.
You start analyzing the data, then one fine day you'll find that the machine is broken down, and you look at the data to understand the data is garbage. And unless you've got an IT support, a very strong IT support to understand and analyze the data is just going nowhere.
We're very complementary because you really come out of the process environment, I come out of the IT environment. That really comes together.
The first thing that typically comes in is when you walk into a plant. It could start with a regular inspection.
When I introduced robots in self-operated routes, they spot a leakage sooner than an operator would do. So even a much smaller leakage would be detected much sooner before they even got someone to pick it. So that's that whole story comes together from collecting various data sources. Of course, it's by data, but you also need often SAP data if you talk about asset type of data, plant maintenance data, which often is stored in the EP environment. All the data we bring then into an enterprise data platform. We apply various parts of analytics on top of it, and then we make it visible in a digital twin or the co-pilot of Microsoft or in a chatbot or whatever. But that is then you bring that whole end-to-end story together.
I was looking at the demo. It's very powerful.
Yeah.
I don't think we had anything similar when we were operating the plant.
I'm very pleased to be here with you for another coffee talk with my friend Rama, and we're going to talk about, from Acuvate, you all should be knowing about Acu7, our 7-step approach, but we're really going to talk about the first 3 steps, really what happens in that whole edge environment, where you collect your data, where you handle your data, where you do your processing, where that's a world on its own. And we can really talk about it for an hour, just what the different thing and the changes happening in that space. So Rama, let me first introduce yourself, then I'll introduce myself. Rama, over to you.
Okay. My name is Rama. Thank you for the invite, Johan. I head a company called Robotics, and we make legged robots for the industrial use cases as well as for the military. My background has been, I've been a process engineer for around 25 years, mostly with gas turbines, boilers, delivering projects around the world. And this is what we do. So I come from a experience in process industries, and this chat is going to probably help us out understand what we could do for the industry with robots.
Very good. And I'm Johan Krebbers. We're very complementary because you really come out of the process environment, I come out of the IT environment. That really comes together. So I'm Johan Krebbers, I'm the CTO for Acuvate. I'm very pleased to be here today as well to talk to you about process. Let's talk about process, because when I have a background in Shell, and in the Shell world we always had the OT guys and the IT guys. Sometimes they never spoke to each other, but that is improving very much so. But maybe start a little bit about, because you have, when I listen to you, have a lot of experience in the process space. What you see as a big change now happening also in process?
Yeah, I think you're right. I mean, when we used to do projects, when we actually go and talk to any company to introduce what we do and how we do it, the first resistance used to be from the IT team, and we always see that there is a difference in either the language or the way they communicate between the problem statements. With OT, I think things are changing now, because a lot of things in OT now start living on the IT platforms, and a lot of things in IT platforms, they also need to understand what OT is doing. So the difference is coming down, is what I see.
Yeah.
But there's still a long way to go, I guess.
Yeah. I always say OT needs IT and IT needs OT.
Absolutely.
The two have to work well together. And I'm very glad, especially in the OT space, you just mentioned that OT space because OT space has been much longer, far more proprietary than IT space has been, because I'm a very old guy. When I was much younger than now, IT was also highly proprietary with your HP networking, with your digital networking, with your IBM networking. Of course, all that went when we went to IP-based networking. But of course, that world is still more existence in an OT space, also changed over there. But it is a little bit more existent over there than in the IT space, but it's also changed over there. It's because it would be good for the OT space to get more in a standard-based environment, I would say, to get more flexibility.
Yeah, it used to be very proprietary, even in the OT space. I mean, like if you go back around 20 years ago, all the legacy companies like either GE or Siemens, I mean, they used to have their own proprietary systems, right from the ladder logics. The data was not exposed. You had to kind of buy their own proprietary connectors to actually read the data. Things have changed significantly. Now, I mean, you can connect to any system because it comes with an open protocol. Once you get the data, it's all in the IT hands to kind of understand and process the data. I see significant changes happening.
No, it's good. But there's still a request in the session this week where people still say, OT people say, well, why do people in IT need our data? And of course, that's an interesting question. But if you think about it, we need to OT and IT data. If you talk about analytics space, you want to analyze the data. You need the two data sources come together. And so that we also, so it's important that also that an OT data is part of that story.
So unless you have IT supporting the data that's, I mean, see in OT, you're generating gigabytes of data on a daily basis if you're looking at a large platforms and stuff. And unless you've got an IT support, a very strong IT support to understand and analyze the data is just going nowhere. I mean, it's just sitting there. And all the new technologies that are coming in terms of, let's say, AI or whatever you guys are doing with the data, unless it is there, you won't make any informed decisions. I mean,
exactly. And that makes it interesting, the world of digital, of course, because with digital, it's the first time, more or less, that type of data is used for decision making. Because in the past, that data was sitting out there. I mean, I remember in my Shell years when we at the Southern Refinery, we were collecting for maybe 30 years OSIs of Pi data, and then we started using that for analytics, and all of a sudden we found that the data was of poor quality. But it was already collected for 30 years because the data was hardly being used.
Exactly.
And all of a sudden we say, oh, now we're going to use it. So it gives a different aspect to the whole thing.
So we used to do a lot of Pi implementations in our in my previous life. This is the same problem that we used to find. I mean, you take data, the data that is getting stored in the legacy historian systems. Whoever commissions the plant, they just put some random settings, and all the data is flatlined. It's not giving you the noise that you need.
Exactly.
And unless you start analyzing the data, then one fine day you'll find that the machine is broken down, and you look at the data to understand the data is garbage. I mean, you need to start collecting data, and you need to start having very robust IT systems to understand what it's telling you.
Because without that, the analytics, the AI, like if you want to use for predictive maintenance, for instance, is a waste of your time. Because you need that quality to say, okay, based on all of that I can see now this is going to happen in the future. But then you need quality data, of course.
Correct. And some of the other things are, when you're actually looking at data, it's also possible that the plant may have a very critical system, but it may not have all the sensors needed. So you come in and when you start extracting data and you understand the process, you also will be able to tell them that for you to understand, let's say, this component, you need a certain pressure or a certain temperature or a certain vibration, and you currently don't have them. And unless you put that in, you will not make sense out of the data. So that is something that AI could bring in as a...
But it also means that it also proves the point again that OT and IT need to work, because OT will know that endpoint, and IT won't really understand the endpoint.
Absolutely.
And so, so that it's so important in a company to be successful that you bring them together. That those two worlds is
absolutely
so important.
And many of the success stories that you see, I mean, you having worked in Shell, you understand how critical it is to actually merge them together. And they absolutely run hand in hand. And I see a lot of companies struggling when this marriage doesn't happen. They work in silos, and that causes a lot of problems.
So they don't make the next step, they don't move forward in a way. And also, if you think of all the new developments, you're also heavily involved in robotics. All the new developments is really based on the fact that these things do come together. Because they might be the robotics might be driven by OT data, but collect IT data again. So if even a company these worlds don't come together, they just miss out on many things.
Absolutely. See, right now the the way we are actually building our robots, if you take our own case, it only gives you partial information. Let's say if I could use a robot to see where there is a leak, or it could just warn you about an impending danger in terms of vibrations, because it could hear some sensors and stuff. But this data, the amount of data it generates is minuscule when compared to the data that's already getting generated, right? So the backbone is still going to be a huge IT infrastructure and the analytics that go in.
But you have some examples, some latest examples, what you guys be doing with robotics in this space, where that will be of interest?
Yeah, so the first thing that typically comes in is when you walk into a plant, it could start with a regular inspection. Well, every plant which is large enough will have plant operators going around in circles. It could be just doing a regular
operator rounds.
Plant operator rounds. Now, depending on the complexity and the criticality of the plant, the rounds could be more frequent. And at times you have to get onto the boiler or a cooling tower or whatever. And human beings, I mean, per se, when you go into the night shifts, and because of whatever limitations we have, the data that gets collected may not necessarily be accurate.
Exactly.
It could be that I feel lazy, instead of an hour, I could say, oh, chip, let me take this data and replicate the data instead of physically going and seeing that. That could be one. And we used to have these things happen. When you hand it over to an operator, you don't know what the quality of the data is. The other thing is, in certain cases, it's very dangerous for a human being to get in. Let's say if you take a closed vessel, we call it as an enclosed entry, enclosed space. Having a robot get in and do the test for you.
Into a tank for an inside a tank.
Inside a tank, exactly. You need. I mean, if you have to send a human being in, a lot of permissions. You need to ensure that it's not a
can be even quite dangerous, of course.
Correct.
Because you can whatever is left in that tank.
Correct. Exactly. So it is laborious. It's time consuming. And it's also not very safe. Robots could do it in a jiffy. I would say.
Yes.
It could be tank inspections. We're working on something that actually cleans the boiler tubes. Usually in the boilers, you've got 100 meters, which depending on the type of plant, you've got 100 meters of water wall, and it's all with soot, and you've got to clean it up. So what happens right now is you make 100 meters of scaffolding and have people go in and clean it manually. A robot could do it in a fraction of the time.
Without the need for scaffolding.
Yes, without the need for scaffolding. So it's funny because the time that actually goes into making the scaffolds is more than the time it takes to clean it up. So, I mean, if you look at all these economics and the safety aspects of it, robots and the associated data that they pump in will do a lot better job.
And the developments go very fast in that space as well. With the robots. You see, if I go back a couple of years, what happened then about now. But also, what's important there, not in all cases, but several cases, that the robot is intrinsic safe, of course.
Correct.
So that which is, of course, specific almost to the energy, all about the energy market, where you need to have that.
So if you look at tunnel inspection or underwater stuff, I mean, right now, if you're looking at cleaning the ships, the hull of a ship, you're having divers go in and do it. I mean, a robot could easily do it a lot faster, a lot cheaper as well. You still need to kind of build the specifics for it, but they do a lot better job. Now, it's not just robots per se. I mean, if you look at how AI is actually affecting it, one small use case is we were trying to build a system that replicates a recoil. And we saw that, I mean, we wanted to put that on a robot actually. We saw how quickly a GPT model can spit out the mechanical design. I'm not even talking about software design. It is, I mean, it's like incredible. I mean, we were testing it out the other day. We had a design and we wanted to see how a GPT model could give it. And it probably got around 80% right. And pretty soon, we'll go to around 99% accuracy.
You just rely on it.
We were stunned to see that.
You just sort of totally rely on that model coming out without the next step anymore. Okay, and we also, if you talk about robotics, you're only talking about, of course, the walking robots. You've got the on wheels or what have you. But of course, drones in a way also robots in that respect.
Yeah, I mean, drones have been there for quite some time now, and people have been using it for something like pipeline inspections. You could do, some of the smaller drones could do gas leaks and stuff. I mean, drones have got their own space. The only regions where you don't probably send drones is, let's say, if you're looking at a pipeline, small pipeline that you want to kind of inspect, or you want to, instead of just the visual feedback, you want to kind of act on it. Let's say you want to clean a pipeline. You need brushes and you need something hard that you could power on. And of course, drones have got some issues when it comes to operating within closed spaces. Now they're trying to overcome that. So drones have got their own space, robots have got their own space. Combining them and getting the data, I think that will solve a lot of problems in the industry.
When I was in one of my previous roles, I was also in Malaysia, where we did the rollout of 5G. We also we used 5G and drones for power line inspection. Because with the help of 5G, you could then, you got your 5G camera, and 5G has the thing, of course, you get a real time, very low latency, high throughput. You could send the data then real time to an edge environment, real time to machine vision on that data, and go back to the drone and say, hey, I go back to that place again because I'm not sure whether it's okay or not. So that was quite a nice extension of what you can do, because 4G you cannot do because there's not enough bandwidth.
Absolutely.
You have to bring the drone back to base, unload it, and then look at the data. But with 5G, you could really do that.
And I do remember doing some of these inspections manually with a thermal camera. You walk around within the switchyard to see where you've got these hotspots. And again, on the boilers, I mean, you've got a boiler stack. There will be hotspots, the exhaust stacks and stuff. It used to be manual now, and the way I do it could be different from the way a next operator or someone else could do it. So there is no repeatability there. And with drones and the robots, you get perfect repeatability.
And you already mentioned that a moment ago, better quality, because when I introduced robots in self-operated rounds, they spot a leakage sooner than an operator would do. Because it was first your product, it's a consistency, but also the better camera quality, what have you, to spot it. So even a much smaller leakage would be detected much sooner before they even got somewhat bigger. Because I mean, the moment you put in a human element there, there's always going to be variability. One operator is going to be good, the other operator is not so good, and you get the timings and all the human factors in it. Even if you do the same, operate the same every day, it will be different.
Exactly.
Because a human being will not be able to say.
Correct.
So, let's talk a little bit about the protocols, because it's also important in the OT. What do you see happening? Like we had in the past OpenC DA, now got OpenC UA. What do you see happening in that whole space from a standardization point of view? So how do you connect your sensors to maybe edge environment? That whole world, how is that changing?
I think it got simplified a lot. Previously, even when you kind of talk about OSI Pi, they've got a lot of connectors to a lot many sensors. Now, I do not know the current status of what OSI Pi is doing at this point of time.
First, it was bought by Aviva.
It's now Aviva.
It's Aviva Pi.
I'm talking about the time that it used to be a few years ago. But at that time, they didn't have, let's say, when I was actually working on with that, we didn't have a visual model. When there is no visual processing or audio processing, because the data OSI Pi is geared for is only process data, either analog or digital. And I don't know if they've got this capability right now.
I don't know either. I mean, I use OSI for me was always the source for your time series data, for your temperature data, pressure data.
Yes, it's purely time series.
And that's really what it's all about.
The most they could do is having connectors to something like SAP, where they could do certain transactional data. But I don't think they've got the visual or an audio data.
No, what we did what Shell developed, and what we now also in Acuvate and Acuprism have. Shell developed on top of Databricks, as a data platform, software called SSIP. Two things. First, it could high-speed streaming of Pi data from across an enterprise into one environment. So that's one part of its solution. And the second solution was storing that data very efficiently in a Databricks environment, and then have the data there for forever. That data can then be picked up by analytics for your predictive maintenance, or even for if there's camera data for your HSSE, for whatever you want to use it for. So what we did with AcuPrism is really we can connect your Aviva Pi and other data sources from your OT space into an enterprise data platform for Shell or whatever company is, yeah? And that is then connected to analytics. And on top of that, what we do is a digital twin. So you have a digital twin on one end, can look at real time at the data which comes out of an OT space, can real time looking at your Pi data, for instance. So that whole story comes together from collecting various data sources. Of course, it's Pi data, but you also need often SAP data if you talk about asset type of data, plant maintenance data, yeah, which often is stored in an ERP environment. All the data we bring them into an enterprise data platform. We apply various parts of analytics on top of it, and then we make it visible in a digital twin or the co-part of Microsoft or in a chatbot or whatever. But that is then you bring that whole end-to-end story together.
I was looking at the demo. It's very powerful.
Yeah.
I don't think we had anything similar when we were operating the plant.
Oh no, it was in the past. Pi, when I was young, Pi data was stayed in an OSAS or Pi environment.
Correct.
Because that was part of the OT space. That was their data model.
And I think the advantage that you bring in when you build something like that is when most of the plants, even now, they've got data in various different silos. They're not interconnected. And the moment you build something that can extract data, even though they're not interconnected, you could directly bring it into a platform.
A common source.
Correct.
Then you can start doing things.
Yes.
And then you also, and that's also interesting then, because then you also see that you now have data from Pi, I got my text from Pi, I got that, let's say from an engine, I got data in SAP about an engine. Of course, the naming convention of all these systems is different.
Correct.
And then what we also had to do is data contextualization, because now you have to start aligning my Pi text with my P&ID, with my piping and instrumentation diagrams, with my ERP data, because all of them are using different naming conventions. And if they then come into a user environment, there's no linkage being made.
Correct.
So what we had to do, for instance, for our digital twin, is contextually aligning, making sure that we aligned together we used AI for that when this tag was linked to this ERP number, was linked to this P&ID number. But then if you go to the user interface, then if you show the pump, of the pump, you could say how it fits into the diagram, what's the P&ID, what is the time series data being collected, and what's the SAP data. But you need all these name conventions are different. So you need to do something to bring them together in the user interface.
And I think one more benefit that I can see with something like that is going to be, people who have run the plants, when there is attrition, the guy who actually has seen a machine completely rip open to put it back, and if he leaves, some critical people leave, some platform like this will help the new guys who have never seen it open, because some machines run for years. You don't have to even open them up. That will help.
Also will help over there things like Gen AI, because and we have also some demos around that, because because a good thing you're talking about over there, because you need then also data maybe from other companies, from what's available on the internet, to help us to collect data about that particular machine to fix it. Because it might not be, very good point, it might not be available in your company anymore.
Exactly.
And then things like Gen AI also become interesting. You talk about ChatGPT kind of things. That's really what becomes of interest then as well.
When I see things changing at such a pace that maybe in a few years you're looking at, I don't know if it is going to happen sooner, but what we see with ChatGPT is 80% in the example that I've talked about. It'll probably reach 90-95% very soon. And I think some of the platforms that you mentioned will help get there faster.
Oh, it will get faster, and we'll also, but of course it will take time, especially in the platform will take time because of the safety risks. Because a lot of these things ChatGPT will get more autonomous. And also you've heard about things like now agentic AI, which in principle, of course, will also become more empowered, and that you have in the background your agentic AI executing certain activities almost independently.
Correct.
But of course, in an energy environment or on a platform, it's more tricky over there. It needs more testing because you can't afford things to go wrong over there.
Yeah, absolutely.
Because there could be an explosion, whatever could happen.
Correct. So even in the robotics, while it's just a flip of a button to make it autonomous or a semi-autonomous thing. I think the end users are not very comfortable in going fully autonomous right now.
No.
Yeah.
That's why I always talk about, if in Acuvate also, we talk about advisory set points. Because at the end of the day, we need, because an operator will not just say, okay,
Correct.
somebody sitting in Hyderabad can make a decision on something in Rotterdam.
Absolutely. Yeah.
That will take some more time before that.
Yeah, it'll get there eventually.
Yeah.
How sooner it's anybody's guess.
Yeah. But so you do need then. It's still good that you get that advisory step and say, okay, we advise based on all the information we received to make this change.
Yep.
And the EOS operator can still say, yeah, but you overlooked this or you didn't think about that, so I'm not going to make it, or I do something else.
Correct.
So that's all that.
Now, what kind of autonomy is it given is something still needs to be tested, I guess.
Yeah, but it will also happen in that space. Yeah. So the whole world of OT will then also change in the next couple of years. Then,
I guess.
Yeah.
How it's going to. There are a few things that we, based on whatever we have seen in the past.
Yeah.
In the plant, when we used to think that okay, there needs to be some calculation that needs to get done, or some small jig that needs to get manufactured.
Yeah.
It used to go through a route of some experienced design engineer sitting and telling us what needs to be done and how it needs to be in the manufacturing stuff. These questions, if I asked in the right sense, the GPT models are spitting out everything, including a schematic and a circuit diagram.
Yeah.
It's not just mechanical part of it; it's even giving the circuit diagram and the control code with it.
And the parts you need, or whatever. So that will totally change and also standardize that environment. And also, which is good because it also will become more standard based and less one product based then. Because because if GPT will brings together, it will try to, of course, use multiple components of multiple companies or whatever. To go away from it needs to be all Honeywell based or Ericsson based or Siemens based or whatever based. So you get that whole mixed environment over there.
Yeah, I think the neutrality of communication, I think it already exists right now.
Yeah.
Not everyone has got a siloed system.
No.
I think everyone is like exposing their data with a common protocol, like something like an OPC or
that's true. But if you look at, for instance, at a refinery where you got one plant, what people don't do is mixing and matching different control systems, like it's either Honeywell driven or Yokogawa driven. In one plant, multiple plants can be different, but over time also that will change because it will become also standard based. In principle, you have standard components that can be from any supplier then. And then so that it becomes even broader, more open than it is already today.
Yeah. It would be interesting to see if a GPT can give me a ladder logic using a Siemens. I can probably ask. I don't know. I've never tried that. I'll try it out. Go ask a question saying that give me a ladder logic or a whatever format that you have. Asking the PLC to do A, B, C stuff, and it should give me the logics that I need to kind of put in and pump it into the PLC. That would be like going to the next level, I guess.
Oh, but that will come.
Eventually, eventually it will happen.
I'm not familiar with that part, but it's happened today. But that will come, of course. That whole space. So there's that whole space with OT. So what do you see as other big developments coming up in the coming years then in that space? Apart from, of course, AI will have a major impact.
Yeah, AI is going to. Now that I see how things are getting changed purely on the OT space. It's hard to predict.
Because nobody would expect it this 3 years ago.
Yeah. I wouldn't have dreamt of it.
No, you would say you out of your mind.
If you had asked me 5 years ago, I would have laughed at it.
Yeah.
And now we see the same thing happening. Very surprising that it's able to do a mechanical design, an electronic design, and a controls code and a software all at the same time with just a question. It's hard to predict with the amount of funding that's going into the AI part of it. the recent stuff that President Trump has pledged
the $500
billion to.
And that's just the US.
Yeah, just the US.
Because you can expect that Europe is going to do something now.
Yeah.
India will do something.
China will do something.
China's going to do something.
Correct.
Because if one start, they all have to do something.
Correct.
So this is only the start of that new cycle almost of activities.
Yeah. Don't know how it. Yeah. No clue how it is going to unfold.
No. But that makes the job also interesting.
Yeah, it's very interesting. Yeah. We'll have to just wait and watch.
Yeah. Of course, you have an OT background, I have an IT background, so we look at how well we can work together. And we'll see how this whole world is come together. And in a couple of years from now, no, we'll talk about OT or IT, we'll talk about this communication.
Yeah.
And it
won't be a different, it's going to blend in.
It will be a blended world.
Yeah, it's going to be a gray area. So, not zeros and ones,
So if you look at this back in a couple of years from now, say, why did we even talk about these kind of things in that being different? Because it all come together in one place.
Yeah.
So hey, good to have a session today. Very interesting. Thanks for your time. And
pleasure was all mine.
We're going to meet again, of course, sometime in the future.
Pleasure was all mine.
Thank you. Thanks.
Yeah, thanks.